Okay, so in the previous lesson, we looked at properties of just parallelograms. So today we're going to look at what I like to call special parallelograms, namely rectangles, rhombi, and squares. So a rectangle, if this will write for me, a rectangle is a quadrilateral with 4 right angles. So it's a special type of parallelogram, which means it has all the properties of a parallelogram and then some. So let's remind ourselves of what those properties are. So first, we have to have opposite sides parallel. Clearly, a rectangle has that. Opposite sides congruent. Again, clearly a rectangle has that. Opposite angles congruent. So we've got opposite sides congruent, opposite angles congruent. What's another property? Consecutive angles are supplementary. And last but not least, what do we have? Diagonals bisect each other. Okay, so those are our properties. This is now the third day we've talked about them. So hopefully they're starting to sink in. Okay, so for a rectangle, of course, they have properties of their own as well. So namely, on a rectangle, not only do the diagonals bisect each other, but they are congruent. So that is to say that AC is congruent to BD. On a rectangle. So let's actually, yes, it's a theorem. If you have a rectangle, then the diagonals are congruent. But let's list it down here as one of our properties. So diagonals are congruent. That's one of our properties of a rectangle. Now, what else is special about a rectangle? Yeah, it's got 4 right angles. In case you didn't know that, that's that many. 4 right angles. So 4 90-degree angles. Those are the 2 properties that it has on its own, in addition to the 5 from the parallelogram. Okay, so let's look at this first example. says a rectangular gate has diagonal braces. Find each length. Okay, well, the first one they ask us to find is HJ. How could I get HJ? Well, I know GK is 48, so that means HJ has to also be 48. So HJ is 48 inches. Then they ask us to find HK. That one right there. Well, I know that JG is 30.8. Actually, take that back. JG is not. JL is 30.8. What would JG have to be then? Well, this one's also down here 30.8. This one up here is 30.8. These are all going to be 30.8. So just add up 30.8 plus 30.8. That'll get you, let's see, 16 carrier 1, 61.6 inches. Okay, then we have the rhombus. So that was it for rectangles. Then we have a rhombus. So a rhombus is a quadrilateral with 4 congruent sides. And it's another special type of parallelogram. So it's got all the same 5 properties of a parallelogram, plus some of its own. So on the back of the notes, we'll look at the ones that it has of its own. So for a rhombus, the diagonals are actually perpendicular to each other. So yes, they bisect, but they're also perpendicular, meaning that BD is perpendicular to AC. So they intersect at right angles right here. Right angle, right angle, right angle, right angle. Those look horrible. Why can I not erase? I'll make a right angle right here. Okay. Also, the diagonals bisect the opposite angles. So if we look at this rhombus here, then angle 1 is congruent to angle 2. Angle 5 is congruent to angle 6. But then 1 and 2 are also congruent to 5 and 6. So 1, 2, 5, and 6 are all congruent to each other. Same thing with angle 3 being congruent to angle 4, which is congruent to angle 7, which is congruent to angle 8. They're all congruent to each other. Okay, so let's kind of put these down here under their own properties for a rhombus. First one is that we have 4, again, that's that many, congruent sides. So a rhombus, all sides are the same. We said up above, diagonals are perpendicular. And we also said that diagonals bisect opposite angles. Diagonals bisect opposite angles. Okay. So let's take these and work an example. So they ask us to find the measure of angle WSR. So that's actually this angle right here. And we can get that by getting y plus 2. Because remember, this angle and this angle are congruent to each other. But now, to get y, okay, so fine. This is y plus 2, got it. What's y? Well, that's over here in this corner, but what do we know about diagonals? How do they intersect? At a 90-degree angle. So I can set 2y plus 10 equal to 90 and solve for y. So 2y equals 80 divided by 2, and we get y equals 40. So for WSR, plug 40 in. We're going to have 40 plus 2, which is 42 degrees. Okay, so that's our rhombus example. Now let's, last but not least, talk about squares. So a square is a quadrilateral with 4 right angles and 4 congruent sides. A square is all of these. So it's a parallelogram. A square is a rectangle. And rhombus. It's all of the above. So that means the square has to have properties of all 3 of them. So for this example, they want us to put all segment measures on the square. Okay, well, this side is 8 centimeters. That means all the other sides have to be 8 centimeters too. And like I said the other day, right triangles, yes, they're gone. I mean, we're done with triangles, but we still have to use some properties. Notice here that one side of a square, or 1/2, makes a 45, 45, 90 special right triangle. So that means our diagonal, the whole diagonal, would be 8 square roots of 2. Centimeters. So that means each individual piece would be 4 square roots of 2, 4 square roots of 2, etc. So, of course, we're in centimeters here. Okay. Second part says put all the angles on there. So I'm going to do what I can here. We're going to say this is a right angle right here. These are 45 degrees over here. 45 degrees right here. 45 degrees right here. 45 degrees right here. Of course, these are right angles up here. This is 90. 90. Here, I'm going to put the symbol instead of writing it. Okay, so we've labeled our square. That means this is the end of the notes. I tried to keep it short, quick, fast. So then that way we'll have plenty of time for the assignment and guided practice. So stay tuned.